Hello all. In today's lecture, we are going to see about full subtractor. This full subtractor is again an example of a combinational logic circuit. In a previous lecture, we saw about half subtractor, right? What does a half subtractor do? Half subtractor does the subtraction of only 2 bits. In case, if there is a borrow that is coming from a previous stage, your half subtractor doesn't know how to process it. In that case, to do a subtraction among 3 bits, we go to full subtractor. Clear? What is a full subtractor? Full subtractor, it is again an example for a combinational logic circuit. Full subtractor is mainly used for subtracting when you have 3 input bits. So how many input bits it will be having? Minimum 3 input bits. Clear? And what are the bits? One is a miniand, subtrahend and of borrow from your previous stage. Clear? And how many outputs it will be giving? 2 outputs. One is your difference, another is your borrow. Clear why we need this full subtractor? In case if you have to do a subtraction among 3 input bits, your half subtractor doesn't know how to do the subtraction. Half subtractor can do a subtraction of only 2 bits. If there is 3 input bits, then you have to rely only on a full subtractor for doing the subtraction. Is it clear? Now, let's see how to design this full subtractor using a combinational logic circuit. As soon as we hear the word design using combinational logic circuit, what are the 4 basic steps that should come to your mind? Whenever you see the word design using combinational logic circuit, what are the 4 basic steps that should come to your mind? First, it should be your block diagram. Then, from your block diagram, you derive your truth table. And from the truth table, you have to derive your Boolean expression, for which you will be requiring your K-map. After deriving your Boolean expression from the K-map, what is your next step? Designing using combinational logic circuit. That is using logic gates. Now, let's see how to draw a block diagram for a full subtractor. Let this be my full subtractor. How many inputs do I have? I've got 3 inputs. Let me assume my inputs as A, B and C. And how many outputs will I be getting out of a full subtractor? I'll be getting only 2 outputs. One is difference, another is borrow. Clear? Now, what is the next step? You have to derive your truth table. How many inputs do I have? I've got 3 inputs. If I've got 3 inputs, how many combinations are possible? If my number of inputs is equal to 3, that is if n is equal to 3, how do I find my combinations? How many combinations will I be getting? 2 power n, which is 2 power 3, it is equal to 8. So I'll be getting 8 combinations and it starts from 0 to 7. Clear? Now write down all the combinations in binary. Clear? Give the equivalent decimal as well. Now, we are done with our inputs. We have to find our output. How many outputs do we have? We have got a difference as well as a borrow. Now, we have to do a subtraction and we have to fill our output table. Clear? Now, let's see how to do the subtraction. We have got 3 inputs. A equal to 0, B equal to 0 and C equal to 0. Now, how do you do the subtraction? A minus B. Clear? Whatever answer you are getting, with that answer you have to subtract C. Whatever answer you are getting here, with this particular answer you have to subtract C. Clear? Whatever answer you are getting after doing the subtraction, this is going to be my difference output. In case if I am doing any borrow, then my borrow will be 1. If I am not doing any borrow, my borrow will be 0. Is it clear how to do the subtraction? Now, for this particular input, this is going to be very easy. A equal to 0, B equal to 0. So, 0 minus 0, it is 0. With the answer, I have to subtract C. C equal to 0. So, 0 minus 0 again, it is 0. Clear? What is this? This is going to be my difference. And am I doing any borrow here? No, I am not doing any borrow. If I am not doing any borrow, then my borrow output will be 0. In case if I am doing a borrow, then my borrow output will be 1. Is it clear? What is the difference output here? It is 0. Clear? Now, let's take the second input. Now, let's take the second input. A equal to 0, B equal to 0 and C equal to 1. Clear? Now do the subtraction. A equal to 0, B equal to 0. I am doing a subtraction. 0 minus 0, it is 0. Clear? Whatever answer you are getting, with this answer you have to subtract C. Now C is what? C is equal to 1. I have to do a subtraction. Can I subtract 1 from 0? No, I cannot subtract. I have to do a borrow from my previous number. So in case if I am doing a borrow, I am taking a borrow from my previous number. Clear? In case if I am doing a borrow, this number will become 10. So 10 minus 1 is what? It is 1. Clear? And I have done some borrow. So my borrow output will be 1. In case if I am doing any borrow, then my borrow output will be 1. If I am not doing any borrow, my borrow output will be 0 as in the previous case. Is it clear? Now, after doing this subtraction, what is my output? This is my difference and this is my borrow. Is it clear? Now, what is the difference output? Difference output is 1 and my borrow output is again 1. Clear? Now, let's take the next input. What is my next input? For this input, A equal to 0, B equal to 1 and C equal to 0. Clear? Do the subtraction. A equal to 0, B equal to 1. So 0 minus 1. Can I subtract 1 from 0? No. So what I have to do? I have to take a borrow. So I'll be taking a borrow from my previous number and then this number will become 10. So 10 minus 1, it is 1. I have done a borrow. So what is the output of borrow? Borrow will be 1. Clear? Now, whatever answer I have got, I have to minus C with it. So C is what? C is 0. So 1 minus 0, it is 1. And my borrow output, I'll be retaining it here. Clear? Now, this is my difference and this is my borrow. Is it clear? So, my difference output for this, it is 1 and my borrow output is again 1. Since I've done a borrow, I've taken my borrow as 1. And that 1 is continuously getting carried over. Clear? Now, let's do for the next input. Let's take this input now, where A equal to 0, B equal to 1 and C equal to 1. I have taken for this combination. Clear? Now, do the subtraction. A equal to 0, B equal to 1. Can I do a subtraction here? No. So, what should I do? I have to do a borrow. Right? Now, 10 minus 1 is what? It is 1. Since I have borrowed from my previous number. So, my borrow output is 1. Clear? Now, whatever answer you have got, with that you have to minus C. So, C is what? 1. So, I have to minus this. 1 minus 1 is what? 0. So, this borrow of 1 will be carried forward. So, my borrow output is equal to 1 and my difference output is going to be 0. Clear? So, for this particular combination, what is my difference output? It is 0 and what is my borrow output? It is 1. Is that clear? Now, let's take the next combination. What is A? A is equal to 1, B and C are 0 and 0. A equal to 1, B equal to 0. So 1 minus 0 is what? It is 1. So with the answer, I have to subtract C. C is what? It is 0. So 1 minus 0 again, it is 1. So this is going to be my difference. Have I done any borrow here? No, I have not done any borrow. So my borrow output will be 0. Now what is the output for this? 1 0 0 combination. 1 0 0 combination. For this, difference is 1 and my borrow is 0. Is that clear? Now, let's take the next combination. 1 0 1. A is 1, B is 0 and C is going to be 1. Clear? Now, do the subtraction. A equal to 1, B equal to 0. Do a subtraction. 1 minus 0, it is 1. With the answer, you have to subtract C. C is what? 1. So, 1 minus 1 is 0. So, this is going to be my difference. This is going to be my difference. Have I done any borrow here? No. So, in that case, what will be the output of borrow? Borrow will be 0. Only if you do a borrow, borrow will be 1. If you're not doing any borrow, borrow will be 0. Clear? Now, what is the output? 0 and 0. Clear? Now, take the next combination 1 1 0. A is 1, B is 1, C is 0. A is 1, B is 1, C is 0. Clear? Do the subtraction. A equal to 1, B equal to 1. 1 minus 1 is what? It is 0. Whatever output you have got, with that, you have to subtract C. Again, 0 minus 0, it is 0. This is going to be my difference. Clear? I am not doing any borrow, so my borrow output will be 0. Clear? What is the output now? Both are 0 and 0. Clear? What is the final combination? 1 1 1. A is 1, B is 1 and C is 1. The last combination. Now, A equal to 1, B equal to 1. Do the subtraction. 1 minus 1, it is 0. Clear? With this answer, I have to subtract my C. C is what? 1. Can I subtract 1 from 0? No. So what should I do? I'll be taking a borrow. So this number will become 10. So 10 minus 1 is 1. I've done a borrow here. So my borrow output will be 1. Clear? This is going to be my difference. And this is going to be my borrow. Clear? Now what is the output for this? It is both are 1 and 1. Is that clear? This is how you'll be filling the output of your difference as well as your borrow. Now, we have got our output. What is the next step? From the truth table, we have got our output. After finding the output, you have to find your Boolean expression. How do you find your Boolean expression? Whatever output you have got, you have to take your output to your K-map, do the positioning, do the mapping, and then derive the simplified Boolean expression. Clear? Now, let's take our output to our K-map. But how many K-maps you require? It depends on your outputs. How many outputs you have? That many number of K-maps you'll be having. Here we have got two outputs. One is for difference, one is for borrow output. So you'll be requiring two K-map. One for difference and one for borrow output. Clear? Now, which variable K-map you will be using? That is based on your input. Depending on your inputs, you will decide on which variable K-map you have to choose. We have got three inputs here, so we will be choosing three variable K-map. Clear? Now, this is for my difference. Let's do the positioning in difference K-map. How do you do the positioning? Check on your output. Wherever you have got 1 on your output, check for the corresponding decimal number. Clear? And against that particular decimal number, whose output is 1? Against that particular decimal number, you have to position 1 in your K-map. Clear? Now, I'm taking only the difference output now. We are doing a difference K-map, so I'm taking only difference output. Check where all you have got 1. You have got 1 output here, 1 output here, 1 and 1. We have got 1 in 4 places. Check for the corresponding decimal number. It is 1, 2, and then this is 4, and this is number 7. So against these particular decimal number, you have to position 1 in your K-map. What are the numbers? It is 1, and then the next number it is 2, then it is 4, and then it is 7. We are done with positioning the numbers in the K-map. What is the next step? Mapping. Can we do any mapping here? No, we have to do only single variable mapping. There is no group mapping possible here. Clear? Now, write down your expression. By default, it is SOP. Clear? Give your expression. For this particular variable, it is A bar, A bar. In SOP, you very well know 0 is represented with the complement of a variable and 1 is represented with the actual variable. Wherever you find 0, you have to complement that particular variable for 0. And if you have a 1, you have to mention that actual variable. Clear? On your horizontal, all the first digits correspond to the letter B. And all your second digits correspond to the letter C. If you find 0, you have to give a complement of that particular variable. If you find 1, then you have to mention them as your actual variable. Clear? Now, let's do it. All the first digit corresponds to a letter B. Here B, it is in 0, so I'll be giving it as B bar. Here again, the first digit is 0, so I'll be representing it as B bar. Here the first digit it is 1, so I'm representing it as B. Here again, I'm representing it using your actual variable. Clear? Now, in a similar way, all the second digit corresponds to my letter C. So here again, C, here the second digit it is 0, so represent that with a bar. Second digit is in 1, so actual variable. C, actual variable, here second digit is 0, so I'll be representing that with my complement of that particular variable. Is it clear? Now, let's write the expression for the first variable. If there is a single variable mapping, you have to include all the elements on your horizontal as well as vertical for that particular bubble. Clear? Only if there is a group mapping, then you will be finding a common variable. Here we are not having any group mapping. We have got only single variable mapping. Clear? Now, let's take this bubble. For this particular bubble, what is here on a vertical? It is A. And for your horizontal, it is B bar and C bar. Clear? Now, take the second bubble. For this particular bubble, what is there on your vertical? It is A bar. And on your horizontal, it is B bar, C. Clear? And for this particular bubble, check on your vertical. It is A. And on your vertical, it is B and C. Clear? Now, the last bubble. For this particular bubble, on your vertical, it is A bar. And on your horizontal, it is B and C bar. Is it clear? Now, do the simplification. From these two terms, which is common? B bar is common. So, I'm taking B bar outside. So, it will be A C bar plus A bar C. And in these two terms, which is common here? B is common. So, I'm going to take B outside It is AC plus A bar C bar. Clear? This expression is representing which gate? This expression inside the bracket. Is it not representing your XOR gate? So, replace this entire expression with your XOR gate. It is A XOR C. Clear? Now, what is this expression inside your bracket representing? This is my XNOR gate. So, replace it. It is A XNOR C. Clear? A XNOR C is what? AC plus A bar C bar. And A XOR B is what? A C bar plus A bar C. All this we have very well studied in our digital logic gates lecture. If you have not seen that lecture, kindly refer to it. I'll give the link of it in my description box for easy navigation. Clear? Now, how can you represent XNOR in terms of XOR? Complement of your XOR will give your XNOR. Right? Now, try to replace it. This is nothing but B bar. I'm going to replace this XNOR gate using XOR. So, how do I replace it? It is A XOR C. The complement of A XOR C gives my XNOR gate. Clear? Now, assume A XOR C as X. I'm going to assume A XOR C as X. Clear? Now, rewrite the equation. This is nothing but B bar X plus B X bar. Check whether these two gates are same. Just that instead of the variable A and C, I've got B and X. The remaining equation is one and the same. Right? So, can I replace it as B XOR X? And now, replace X with A XOR C. This is same as B XOR A XOR C. Rewrite it. A XOR B XOR C. Clear? This is the output of my difference. So, what do you infer from here? By doing an XOR combination of all your inputs, you're going to get your difference. Is it clear? So, mention it here. Difference is nothing but A XOR B XOR C. We are done with finding the difference output. Now, we have to find a borrow output as well. Let's see how to find your borrow output. Here again, we will be requiring 3 variable mapping because we have got 3 inputs. Clear? Now we have drawn a K-map for a borrow output. We have to position the numbers inside the K-map. How do you position the numbers? We are considering the borrow output now. Fine? Now, in a similar way, how do you position the numbers inside the borrow output? You have to check for your output. Wherever you have got 1 on your borrow output, check for the corresponding decimal number. And against that particular number, whose output is 1, against that particular decimal number, you have to position 1 in your K-map. Clear? Now, let's see where all you have got 1 on your borrow output. We are considering only borrow output here. Fine? Check where all have you got 1. You have got 1 here, 1 here, 1 and 1. You have got 1 in 4 places. Check for the corresponding decimal number. You have got 1 here, you have got 1 here, you have got 1 here, and then you have got 1 on the last number. Clear? Against these decimal numbers are nothing but the decimal number inside your boxes. Now, against these decimal number, you have to position 1 in your K-map. Clear? Now, what are the numbers? It is number 1. So, against 1 you position, against 2, against 3, and then against number 7. Now, try to do a mapping. We can do a mapping here. We can do another mapping here. We can do another mapping. Clear? Now, try to give the equation. Here, it is a group mapping. Whereas in the case of difference, what we got was only single variable mapping. Since it was a single variable mapping, we took all the variables on a vertical as well as for a horizontal for that particular bubble to write the Boolean expression. Whereas here, we have got a group mapping. If it is a group mapping, then here again we have to see both the horizontal and vertical. But you will be taking out only the common term for your Boolean expression. Clear? Now, let's take this particular bubble now. For this particular bubble on your vertical, fill these variables as well. For this particular bubble, check on your vertical. Now, this A bar is common to both the numbers inside this bubble. Right? So, this A bar, since it is common to both the numbers inside your bubble, I am going to take it as such. Now, for every bubble, you have to check vertically as well as horizontally for writing your midterm. We are done with checking vertically right now. Now, go for checking the horizontal as well. Here, for this particular bubble, for this particular one and for this particular one, check horizontally which is common. Here, the first variable, here it is B bar, here it is B. Both are varying. Now check on the second term. Here again it is C, here again it is C. So both are matching. So this is the common term for this particular bubble on your horizontal. So include that. Is it clear? Now check for this particular bubble. For this particular bubble on your vertical, again A bar is common. So I'm going to write A bar. Now check horizontally. While checking horizontally, which is common? Here the first variable it is B, here again B. B is common, so B I'm going to write. Now check for the second variable. Here it is C and here it is C bar. Both are varying. C and C bar are different, right? So I'm going to ignore that. Only the common term I'm going to write it for my min term. Is it clear? Now I'm done with this bubble, I'm done with this bubble. Let me take for this bubble. For this particular bubble, for these two ones, check on your vertical which is common. Here it is A bar, here it is A. Both are varying. I don't have any other variable here. There's only one variable and it is differing here and here. So I cannot take any variable here on my vertical. Now check horizontally. This B and C is common to both the ones inside this particular bubble. So I'm going to include B and C. Understood? This is how we will be writing the Boolean expression for a borrow output. See if we can do any simplification here. No, we cannot do any simplification. So this is going to be my final Boolean expression for the borrow output. Clear? Now, we have got the Boolean expression for a difference and we have got the Boolean expression for a borrow as well. What is the final step in the design procedure? You have to design it using logic gates. Now, let's see how to design it. For designing, how many inputs we have? We have got 3 inputs. Let me draw the difference now. What is difference? Difference output is nothing but the XOR combination of all the 3 inputs. So all the 3, let the inputs be A, B and C. Clear? XOR combination of all the 3 input is going to be my difference. XOR combination for all the 3 input. This is going to be my difference. There's nothing but A XOR B XOR C. Is it clear? Now, in a similar way, we have to design the circuit for a borrow output as well. So, in borrow output, we have got 3 min terms. So, let's do it step by step. Let's take the first min term now. What is the first min term? It is A bar C. I've got A input here. So, from A input, I have to convert it into A bar. What should I do? I have to feed it inside my NOT gate. Clear? The output of your NOT gate. This is also called as an inverter gate. So whatever input you are giving here it is A. After passing to NOT gate, it becomes A bar. Clear? A bar and C. With A bar, I have to take C, and what they have done here, this is a product term. So for product term, which gate you will be using? AND gate. So these two terms, I am going to feed it inside my AND gate. So what is the output of AND gate? It is A bar C. Clear? Now, we are done with the first term. Let's move on with the second term. What is second term? It is A bar B. I already have A bar here. So, let me take A bar from here and along with A bar, I have to take B. So, from here, I'll be taking B. Clear? These two again. This again is a product term. So, for a product term, I have to feed it inside an AND gate. The output of this will be A bar B. Is it clear? What is my final term? It is B and C. So, B, I have it here. C, I have it here. So, these two terms, I am going to take it. This again is a product term. So, I have fed it inside a AND gate. The output of this, it will be B and C. Now, all the 3 min terms, what have they done here? They have done an OR, which is nothing but they have summed it up. For summing, which gate you will be using? You will be using an OR gate. So, the output of all the 3 gates, I will be feeding it inside an OR gate. This is my borrowed. Clear? This is how you will be designing a full subtractor using combinational logic circuit. Let's sum it up. In today's lecture, what did we see? We saw what a full subtractor is and how to design this full subtractor using combinational logic circuit. For designing, what is the first step? We drew a block diagram, and from your block diagram, we got a truth table. And from the output of your truth table, we got the simplified Boolean expression using K-map. And after finding the simplified Boolean expression for both your outputs, that is for difference as well as for borrow, what is the final step? We have to design the circuit using logic gates based on your Boolean expression. Clear? And this is how you'll be designing a full subtractor using combinational logic circuit. I hope you are clear with this lecture. If you find my lecture useful and informative, please like, share and subscribe to my channel. Thank you.